Now, effect of dielectric on capacitor. Effect of dielectric on capacitor. Electric field between the plate. Electric field between the plate. Energy and charge between the plates. So many different aspects we will see when dielectric slab is introduced between the plates of capacitor. First thing is that, let this is your capacitor. This is in air and its area of the plate is your A, gap between the plates is D. So right now, since it is in air, so we can write C naught, which is your epsilon naught A by D. So capacitance in air is given as epsilon naught A by D. Okay, now there are two aspects of this type of question. One, first case, capacitor is charged with a battery, then battery removed. Capacitor is charged with a cell of EMF V, then cell is removed. Okay. So it means when it has been charged with a cell of EMF V, so charge on capacitor Q naught is your C into V, or C means in air, C naught into V. The first thing is that, important point, after removing the cell, charge on a capacitor will remain same. So after removing cell, charge on capacitor remain constant. First very important point. So this is the now charge Q naught, which is remain your C naught V, and capacitance as you know C naught this. So now space between the plates filled with dielectric of dielectric constant K, of dielectric constant K, like this. Dielectric constant K. So here we will write the value without dielectric constant, here all value with a dielectric constant. The charge Q, electric field E, energy U, potential V, all these value, and capacitance C. So first thing is that charge on this your capacitance your C naught, charge is your C naught V, electric field between the plates is your, one is positively charged, another negatively charged. So electric field between the plate will be your Q naught by A epsilon naught, and energy, potential your remains same, potential V naught your V, and energy U naught. U naught can be written as half C naught V naught square, half CV square. So these are all value after charging, then battery we have removed. Now due to introduction of dielectric slab. First thing, as I said, whenever we have removed the battery, so no device left which can maintain the flow of charge between the plates. Since no device left which can maintain the flow of charge between the plates, so charge on the capacitor plate will remain your constant. The first thing is that here Q will remain your Q naught. Second point, capacitance. As we said, after introduction of dielectric slab, here dielectric slab is completely filled the gap between the plates. So capacitance will increase by a factor K. The new capacitance will be your K times C naught. After that, if we are talking about potential, as we know, potential is given as charge by capacitance. The new potential V, charge by capacitance, the Q naught by K C naught and Q naught by C naught. Q naught by C naught is your initial capacitance in V, V nothing your V naught. So V naught by K. It means what can be said, charge remain constant, capacitance increases by factor K, but potential decreases by factor 1 by K. Now energy or electric field. Electric field, if I am talking about, electric field is nothing, potential by the separation between the plate. So as potential decreases by factor K, electric field will also decrease by a factor K. Now energy. If I am talking about the energy U, as here energy or half CV square, half C into V square. So here K times your decreases, so energy your decreases by U naught by K. So in the first case means here capacitor is charged with a cell of EMF V, then cell is removed. So charge will remain constant, capacitance will be your K times increases, potential your K times decreases, electric field also K times decreases, and energy stored between the plates of capacitor also decreases by a factor K. And now second case. Second case means, okay, capacitor is charged with a cell of EMF V and battery remain connected. Now see the second case. So capacitor is charged with a cell of EMF V and battery remain connected. Battery remain connected. So right now Q naught is the charge on the capacitor, battery remain connected. So first of all, so whenever battery remain connected, so potential difference between the plate will remain your constant. Since battery remain connected, so potential difference between the plates remain constant. This is the important point here. Potential difference between the plates remain your constant. Now, so before connecting this or before inserting dielectric slab, see the other values. The capacitance your C naught, potential your V naught, let V naught is nothing, it is the V equal to V, V of the battery EMF, charge. Charge is your C naught into V, energy. Energy your half C naught into V naught square, and electric field. Electric field E naught, and which is your nothing, V naught by D. D is the gap between the plate. Now Now dielectric slab of dielectric constant K inserted between the plates, then see, it means important thing is that our battery remain connected. So once the battery remain connected, so what is the important factor here? It will come. First thing, when battery remain connected and due to insertion of dielectric slab of dielectric constant K, first of all, capacitance will increases by a factor K. So new capacitance will be your Kc0. But what will happen as soon as we are inserting dielectric slab here? So polarized charge will develop, and polarized charge will decreases the electric field between the plate. As electric field between the plate start decreasing, potential difference between the plate start decreasing. So equilibrium will break. So equilibrium break, since battery is still connected here, so that battery will try to maintain the potential difference between the plate. So charge start flowing from one plate to another plate through the cell. So finally battery will maintain the same potential as potential before. So V is remain equal to your V0. It means after inserting dielectric slab potential and before inserting, the potential will be your same. Next, if potential same, the gap between the plate has not been changed, so electric field between the plate will also remain your same. So E will remain your E0. Now if I am talking about the charge between the plate, charge is equal to your C into V. So charge, that's why now for maintaining the same electric field between the plate, charge has flown from one plate to another plate, so charge increases. So that charge will be your K times initial charge. Your K times initial charge. And now if I am talking about the energy, since charge has been flown from one plate to another plate, so battery has done some work, some energy. It has supplied some energy. So that's why the energy in the plates will increases. So half CV square, if I am using the formula for energy, so that will come your K times initial energy. So these are the factors which changes, and these two different situations. In the first case which we have discussed earlier, on that case battery has been charged, then the battery has been removed, and in the second case battery still remain connected. In this case, see the factors which are changing by the insertion of dielectric slab.